Hello students, welcome to Ajay's classes. In this video, we are going to cover all the remaining concepts of chapter motion. So welcome to part 2 video of motion. Let's get started. Average speed. Average speed is the total distance divided by total time taken. So whenever you are going to find out average, you are going to consider total values. Okay, the average of total values. So let's go forward. Average velocity. Average velocity is total displacement by total time taken, and SI units will be same as speed and velocity, which is meter per second. Next we have acceleration. Acceleration is the rate of change of velocity. Yes, the rate of change of velocity is called as acceleration. So now acceleration can be positive, negative, or zero as well. Okay, so based on the situation, we are going to have positive. When we speed up the vehicle, positive acceleration. When we slow down, when we apply the brakes, then negative acceleration, which is also called as retardation. And zero when the vehicle is moving with the constant speed. Okay, the formula says the acceleration is equals to change in velocity by time taken. That means final velocity minus initial velocity divided by total time taken. So we know that final velocity will be represented by v and initial velocity will be represented by u, and time is t. So when final velocity is more, that means you are increasing the speed. Initially it will be less only. When we increase the acceleration, the speed will be more. So when we increase, when we give positive acceleration, final velocity will be more. So then you are going to have positive acceleration only. No, here in the formula, final velocity will be more. Initially, it will be having less value. So v minus u will be positive. So you are going to have positive acceleration. So if you apply the brake, so then what happens? Initially, you will be having maximum speed, and when you apply the brakes, the speed gets reduced. Then what happens? Final velocity will reduce. So then you are going to have less value minus higher value, which is negative acceleration, which is also called as retardation. When you apply the brakes, it will happen. Okay. Next, zero. When acceleration will be zero? When speed is not at all changing. For example, you have some 60 kilometer per hour speed. You are not at all changing the speed. Speed is constant now. What will be final? What will be initial? Both are same. So whenever v and u both are same, then v minus u will be 0. So then entirely acceleration will be 0. Okay. SI unit of acceleration is meter per second square. Yes. Next, we have uniform and non-uniform motion. So let's understand about uniform and non-uniform motion. First, uniform motion. The object covers equal distances in equal intervals of time. Yes. For example, for 1 hour, if the object covers 50 kilometers, next 1 hour also 50, next 1 hour also 50 kilometers. So if it covers equal distances in equal intervals of time, then it is called as uniform motion. So let's see an example. Here there was a car, so which has traveled from point A to B, then C, D, E. Okay, so from A to B, it has taken only 1 second, which is a 5 meter distance. Then next one is another 5, which is one more second. Next 5, one more second. Next 5, one more second. So it has covered 5 meters in each second. So this is called as uniform motion. Next we have non-uniform motion. It says the object does not cover equal distances in equal intervals of time. Example, if you see, the car is traveling from A to B, B to C, C to D, and D to E. Now let us see the timings. The distances are same only from A to B, B to C, C to D. And here the timings, if you see, first 5 meters 2 seconds, next 5 meters 0.5 seconds, and next 5 meters 0.5 seconds. Again, for the next 5 meters 2 seconds. That means it is covering equal distances but in unequal intervals of time. So it is called as non-uniform motion. Okay, I hope you have understood. So it is like example for non-uniform motion, car moving in a traffic. Sometimes it has to increase the speed. Sometimes yeah, they have to apply the brake and so many things, right? The speed is not constant. Okay, so then it is considered as non-uniform motion. Let's go forward and understand the important concept, which is graphical representation of motion. Uses of graphs. It helps to represent the complicated data in a simple format. Yes, so to see and analyze the data is not so easy. But if you represent graphically, we can easily understand. Next, we have to find velocity, speed, and acceleration. For that also we can use the graphs. To analyze the type of motion, yes. What kind of motion it is? Is it accelerated or decelerated? Different types of motions we can analyze. And behavior of motion also we can analyze, which is it uniform motion, non-uniform motion, right? So accelerated motion, decelerated motion, or rest. Yeah, everything we can analyze by using these graphs in a very easy manner. Let's understand different types of graphs also. So in this chapter we have distance time graph, displacement time graph, and velocity time graph. All the three different types of graphs we have. Let's understand one by one. First, distance time graph. Let's understand distance time graph in detail from one point to other. Then we'll go for the next one. Distance time graph. First graph, if you consider, here we will represent distance along y-axis and time along x-axis. If you consider a motion which is happening from origin and it is moving, it is covering some distances in some particular time intervals. Okay, so let's understand one by one. First, some distance is covered in some time. Okay, next some more distance is covered in some more time. Then it goes, the object is moving, let us consider. So you will be having different distances which are covered in different time intervals. If you analyze here in this situation, you can see what kind of distances are covered here. You can see equal distances are covered, right, in equal intervals of time. So let me help you with a number with a pen. Okay, so let us write 1, 2, 3, and 4. Here we'll write distances like 10 meters, 20 meters, and 30 meters, 40 meters. Okay, so if you consider for first 1 second 10 meters it has covered, then another 1 second 20 meters, then third second 30 meters. That means it is covering 10 meters in every second. So can we call it as uniform motion? Yes. And if, what slope says here, the slope equals to y2 minus y1 by h2 minus h1. So actually the distance time graph, if you consider, the slope of distance time graph will give you the speed. We discussed about the uses of graph, right? So here, to find out speed using distance time graph, you just have to find out slope. So the slope formula is already there. So delta y by delta h, or y2 minus y1 by h2 minus h1. Okay, so next we have this graph. What it represents? It represents uniform motion with a positive slope. So how it is positive slope? If you consider any one triangle, okay, from here to here we'll consider one triangle. So let us consider A, B, and C. The slope, what it says, y2 minus y1 by h2 minus h1. So if you consider here in this situation, what will be y1, what will be y2? So y means y-axis, x means x-axis here, y values. So y2 is the final y2 value. Final y value is y2. Initial y value is y1. So final y2 value is this one, right? At A, point A. So which will give you 40. And y1 value is the initial y1 value, which is this point in that particular triangle if you consider. So that is 30. So 40 minus 30 divided by, you are going to have h2 minus h1, which is the time. So h2 is final, which is 4, and initial time for that particular triangle is 3. So if you solve it, what you will get? You will get 40 minus 30, which is 10. Okay, once again. It's 10, right? Yeah. 10, 10, 10. So 40 minus 30, which is 10, divided by 1. So it is 10 meter per second. Is it positive or negative? It is positive, right? So 10 meter per second is the speed. So from this graph, you will understand it is uniform motion with positive slope. Next, it covers equal distances in equal intervals of time. So we have already discussed it. Next, we'll go to other graph, which is showing the same kind of distance and time, which is along x axis and y axis. Here, we have something, some object is moving in a particular direction. Is it moving or not? Let's see. So now if you consider for 1 second, what is the distance here? 2 seconds, there only. It is not changing. It is not changing. The y-axis is not changing. It is just in a straight line. That means if you consider here, it's like 20 meters. Okay, so here 10 meters, then here 30 meters. It is at particular position. It is not at all changing. For 2 seconds, no change. For 3 seconds, no change. 4 seconds, no change. That means whatever the time is increasing, but object is there only. It is not traveling. So we can call the object is in rest position. And slope, if you consider, slope is 0 because y2 minus y1. So y is not at all changing. Y2 is also same, y1 is also same. So slope is 0. Speed is 0. Speed 0 means the object is not moving at all. Next, distance is not at all varying with respect to time. That's why speed is 0. Next, we have distance time graph in a different way. Oh, what we have now? Let's see. Yes. How? The distance is covered in different ways. Okay, let's see. Let's have some timings here. Okay, so you have to mark equally. 1, 2, 3, 4, 5, 6, 7. Let us translate in this way. So here 10, 20, 30, 40, 50. In that way we'll consider 10, 20, 30, 40, 50. So here what's happening? For 1 second, it has covered almost 10 meters. For 2 seconds, it has covered almost like 20 or 30 will consider. For 3 seconds, it's there only. It's not covering much. So it is covering almost 31 or 32, something like that. But for 4 seconds, again, it's around 30 only. But fifth second, again 40. Sixth second, 50. 7 second is almost like it's already above that. Within 6 seconds only, it is covering almost 60 or 70 meters. That means it is covering unequal distances in equal intervals of time. If you consider for 1 second 10 meters, 2 seconds 20 meters, 3 seconds 30, 4 seconds same 34 or 33. That means it is not covering equal distances. From this graph, what we can analyze is it shows non-uniform motion. It is not covering same distances in same intervals of time, and the speed is changing. So then only, right? Sometimes equal, sometimes more distance, sometimes less distance, sometimes it is not even covering more. Okay, so it is not covering equal distances in equal intervals of time. Okay, next we'll go for the displacement time graphs. Yeah, distance time graph is over. Displacement time graph is also almost similar kind of thing. So let's understand step by step. Next we have displacement time graph. The first one, let's see. Displacement time graph will be having the same kind of distance time graph. Okay, same to same only. So here we have displacement instead of distance. Okay, so here we'll consider object is moving in a particular direction. So it is having some particular straight line from the origin. So first it covers 10 meters. Let us consider in 1 second. Next another 10 meters in another second. Right, 2 seconds we'll consider. Next 10 meters, 30 meters. Let us consider another 1 second, which is 3 seconds. So like that, it is going to cover equal distances or equal displacements. Yeah, displacement time graph. Equal displacements in equal intervals of time. So here also we will find out the slope. To find out slope, we need y2 minus y1 as usual. Same, just like a distance time graph. Here it will give you the velocity. The slope of displacement time graph will give you velocity. There in the distance time graph, it will give speed. Here velocity. Okay. What this graph says? It represents a uniform motion. The slope is positive, which is velocity. The slope will give you velocity, which is positive. Uniform motion. Remember, it is increasing, right? Displacement is increasing. Displacement is increasing with time, and it is covering equal distances in equal intervals of time. That we have already seen, right? For 1 second 10 meters, another 1 second, another 10 meters. Okay, equal distances are covered. This graph is also example for uniform motion. Remember, so you can get in exams like they will give you a graph you have to find out what kind of motion it is. Yes, if it covers equal displacements in equal intervals of time, uniform motion. So this graph is example for uniform motion. Next, one more graph. So here, displacement and distance, yeah, displacement and time around y-axis and x-axis. So here the motion, just like distance time graph, the displacement is not at all changing whatever the time. The time is moving, there is no change in displacement. So here what do we get? It shows an object is in rest position. The slope is 0 and the velocity is 0. The slope is 0, that means y value is not changing, no. So y2 minus y1 is 0. So velocity is also 0. So it says the displacement is not at all covered. Okay, so the time is varying, but the displacement is not covered. Next, one more graph for displacement time. Again, so here what's happening? Oh, it's a different thing. Just like for distance, we don't have this kind of graph. For displacement, we have it. So here, if you see, what all things are changing? Actually, the displacement is decreasing. Can you see? The displacement is decreasing. It is coming downward. For time is increasing, the displacement is decreasing. Can you observe here? So from this, what you can understand? It represents the negative slope, right? When you find out a, B, C, if you write, what is slope? Slope equals to y2 minus y1 by x2 minus x1. We can also call like AB by BC. So you should understand in different ways, right? So what is AB? AB is y2 minus y1. So y2 is here, okay? Y1 is here. Which is more? Y1 is more. So when you consider y2 minus y1 by x2 minus x1 in this condition, y2 is less minus y1 is more, then you are going to have the time is as it is increasing only, the time is increasing. So here you are going to have positive value at the denominator. So but here you are going to have negative value, right? Because y1 is here, y2 is here. If you consider the values of y1 and y2, based on that you are going to have negative value. That's why the slope is negative, so velocity is negative. Okay, so hope you have got it. Next, I think final displacement time graph that you are going to analyze here. And here what it shows, just like distance time graph, here the displacement is varying differently. The displacement is changing. Here, what is not constant? The speed. Yes, the velocity is not constant. It shows non-uniform motion. It is covering different displacements in equal intervals of time. Okay, so equal distances are not covered in equal intervals of time. So it is non-uniform motion. So if you have any curve in displacement time graph, so it shows non-uniform motion. Next, displacement time graph can be understood within a single graph. If you understand one graph, it is more than enough, but observe carefully, it's very important. So here displacement and time as usual, x-axis time, y-axis displacement. So now if you consider an object starts from point O, okay, so it moves some displacement, it moves some distance or displacement, and the point E, it will stop. Okay, so now what kind of velocity you're going to have in this condition? If you find out slope, you're going to have positive velocity. Okay, remember this, you're going to have positive velocity. Next, object starts from A to B. The time is moving. Okay, the time is moving. Does the object change its position? No, it is in the same displacement. Can you observe? The displacement is not at all changing. It's in the same level. That means it's in rest. That means velocity is 0 from A to B. Next, if you consider, if it is moving from B to C, okay, from B to C, if you consider, the displacement is decreasing. Whenever there is a decrease in displacement, then if you find out the slope for this graph, which is decreasing, you're going to have V equals to negative. The slope is negative. I hope you got it. So if you understand this particular graph, you can understand entire displacement time graph completely. Okay. So the slope of displacement time graph, as usual, it will give you Yeah, slope of displacement time graph will give you velocity. And next go to the velocity time graphs. Okay, velocity time graphs in detail we are going to study just like displacement and distance time graph. Very important, please observe carefully. If not, you can just go back and see again. Yes, velocity time graph. Here also first condition, velocity along y-axis, time along x-axis. Here, what is constant? Okay, so let's understand from this curve, like a straight line, which is green color. Is the motion like uniform or non-uniform? Is there a motion or not? Yes, there is a motion. See, the velocity is constant. It is not zero, right? So it may be some 20 meter per second or 30 meter per second. But when the time is increasing, there is no change in the velocity. The velocity is constant. Okay, the velocity is constant. That means it is example for uniform motion. And the slope of velocity time graph will give you acceleration. You know how to find out slope, right? So the slope of velocity time graph will give you acceleration. Next, it shows the uniform motion and the velocity is constant. When the velocity is constant, acceleration is zero. Can you find out slope of this line? What is slope of this line? Zero, right? Y2 minus y1. So y-axis is not at all changing. So it is zero. Slope is zero. That means acceleration is zero. Yes. Next, equal displacements are covered in equal intervals of time. Yes. If the velocity is same, right, it will cover equal distances only, right? So if the velocity is like 60 kilometer per hour, if you consider in that way, every 1 hour it will cover 60 kilometers, right? So it will cover equal displacements in equal intervals of time. So uniform motion. So this graph shows uniform motion. Next, one more example, one more graph. Here, the representation will be kind of different. Yeah. Does it show non-uniform motion or uniform motion? It's increasing. Yes. It shows non-uniform motion. Acceleration is constant. See here, if you find out slope of this graph, acceleration is constant. You can find out here or wherever you find out. Acceleration will be same only. Acceleration is same means, for example, we'll go for this only. For first second, it is having 10 meter per second. For second, it has 20. Then third, 30. So it is increasing, right? It is increasing. So whenever, with respect to time, the speed is increasing, if speed increases, automatically distances which are displacements are covered will also increase, right? Which is not same. So in 1 second, it can travel 10 meters. If you increase the speed to 20 meter per second, in a second it can travel 20 meters. If you increase the speed to 30 meter per second, in a single second it can travel 30 meters. That means the speed is increasing continuously, so displacements are not covered equally. So it is non-uniform motion. Okay, so acceleration is constant. When the acceleration is constantly you are increasing the speed or using the acceleration, then you are going to have non-uniform motion. And equal displacements are not covered in equal intervals of time. So let's go forward. One more graph for the velocity time. So same as usual. Yes. Here, what's happening? What you can understand from this graph? If you find out slope, you're going to have positive or negative. Slope is negative here, right? So initial point is here, initial point, and the final point is here. So then if you find out y2 minus y1 by x2 minus x1, the slope, what you're going to have, positive or negative. So y2 is this one, dun, 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 dun. It's y1 is this one, right? This one is y2, y1 is this one, and this point will be h1, this point will be h2. So how the motion of the velocity changes with respect to time, in that way only you have to take y2 and y1. So y2 is more or y1 is more? Here if you see, y2 is less, y1 is more, so automatically you will have negative value. In the bottom you are going to have positive only, so finally you are going to have negative slope. Okay, so the acceleration is negative in this case. Equal displacements are not covered in equal intervals of time. So here this one is also non-uniform motion because velocity is changing. If velocity increases or decreases, whatever, here the acceleration is not constant. It is retardation which is constant here. Acceleration is not constant now. It is retardation. So negative acceleration is happening, but equally it's happening. Okay, so it's having negative acceleration. So let's go to the next one now. Even the velocity time graph also we can understand in a different way. The distance time graph and velocity time graphs are like almost like opposite. So if there is straight line, it is at rest. If here it is straight line, it is in uniform motion in velocity time graph. So be careful while analyzing the situations. Next we have velocity um, time graph for, yeah. So here what's there? The velocity is changing in a different way, right? So here we can consider it as a non-uniform motion because the acceleration is not constant. Sometimes you will give more acceleration, sometimes you will give less acceleration. From here to here, acceleration is like raised so faster. From here to here, there is no much acceleration. You are not applying more acceleration. But when you go to the next one, again acceleration is increased a lot. Slope is more. Okay, so that's why it is non-uniform motion. Equal displacements are not covered in equal intervals of time, so non-uniform motion. Let's understand the entire velocity time graph in a single graph now. Just like displacement time graph we did, no? Yeah. So here, velocity as usual y-axis and time along x-axis. When if we consider object is starting from rest at point O, it covers some distance from O to A with a velocity. From O to A, it is increasing the velocity. Okay, so while increasing the velocity, what will be the acceleration? Acceleration is positive. You are giving acceleration which is positive, then only speed will increase. No, if you accelerate, then speed will increase, right? So next we have the condition. The velocity is constant. It is not changing from A to B. The velocity is constant. What will be the acceleration? Acceleration is slope, so it is 0. A equals to 0. Next, from B to C, if it is going. Okay, so what will be the velocity? Velocity is increasing or decreasing? You can see here, velocity is decreasing. Initially, it will be having more at B. When it is coming downward, automatically the velocity is decreasing. Y-axis is velocity, right? It is decreasing. So then what will be the slope? Slope is the acceleration as well. Is it positive or negative? It is negative. You're going to have negative slope. Hope you have got it. So in a single graph, you can analyze and understand the entire velocity time graph, right? So hope you've understood. In this graph, what you're going to see, the acceleration. The slope gives acceleration, and one more extra thing that you're going to learn. So if you find out the area under this entire curve, okay, the total area, if you consider, it will give you the displacement, the total displacement. What is the area? Length into breadth, right? For the rectangle. For the triangle, if you consider from here to here. Okay, so here if you divide, two triangles are there, one rectangle is there, right? One triangle, the second triangle, and this one is rectangle. So here you are going to find out area of two triangles and area of rectangle, which is going to give the total displacement. Okay, so here if you find out velocity into time, so if you find out area for the rectangle, so what you have to do, AB, let us consider EF. Okay, so area of rectangle ABEF will be AB into EF, right? Like AB into BF or AB into AE or EF into BF, whatever you can consider. You are going to have area of rectangle, right? So area of rectangle will be length into breadth here. Length is, you can consider it as AB. Breadth, you can consider it as AE. So what is AB? AB shows time, right? Time. Whatever AE shows velocity. So AB into AE, which gives you velocity into time. So velocity formula is displacement by time. So displacement equals to velocity into time. Yes. Did we get displacement here? Yes. Area under the velocity time graph will give you displacement. Hope you have got it.